I hand over to Florian, who is presenting Catch-up 360 digital benefits for physical artifacts.
Welcome to my talk. I will present Catch-up 360, where we try to apply digital benefits to physical artifacts. My name is Florian Perteneder. I'm a PhD student, and this work was done at the Media Interaction Lab in Hagenberg, Austria. So when we work together with designers, we see that they like to craft with their hands rather than work with digital tools like 3D or CAD drawing programs. So we tried to lift this working style and add possibilities that you usually just know from the digital world to this physical modeling. So for instance, we tried how to share mockups over distance and how to store artifacts and retrieve them later from an archive. This work was very much motivated by our work together with the LEGO Future Lab group, where they're building a lot of brick models, and also with furniture designers who work with scale models. And together with those collaborators, we tried to first identify the benefits of physical artifacts. So first comes what I've already mentioned at the very beginning. It's very important to them to have an intuitive way of creating and modifying their models. And of course, the haptics play an important role. So it's important to them to grasp and to touch an object. What's important, moreover, is that you have the geometric properties so that you can look at the model from different perspectives and see how the shapes align with each other. And the last thing that's also very prominent in related work is the communication part. So a physical object allows people who just pass by to see what the person is actually doing, and this way allow for a communication, a good communication starter to start talking about their work and engage in communication and add different perspectives. But what are the drawbacks? So the drawback is that a physical artifact is very hard to share. So for instance, with LEGO talking, as they have many divisions over the entire world, they even go so far to build a model twice and ship the one to, for instance, LA and keep the other one in Denmark, Billund, because it's much harder than building the thing in a digital way, sending the blueprints over there and then rebuilding it there. The second thing, it's hard to archive. Even though big companies or also furniture designers, they have cellars and archives where they store the physical models. Nevertheless, seldomly somebody goes down there and actually retrieves the right box, unpacks it, and so on. And this is where our system tries to provide a benefit. And so I'll show you a video how this is done. So here we see the prototyping task, for instance, building a physical model. And what you can't really see is that in the base plate there is an RFID tag that should later identify the model. And this is happening when the model is actually then placed on our Catch-up 360 system. So as soon as this happens, the system then tracks tracks the object by rotating it, and a series of images captures the object in 360 degrees. So then we have different possibilities of adjusting communication. So first of all, just adding simple notes, and by tapping on the Arduino on the Anoto surface, these notes are digitally stored. And as it's mounted on a pedestal, the idea is that this turntable actually acts as an anchor of communication where people can pass by locally and also add to the nodes there. And what's then unique about the system is that you can also remotely access it via a very thin web client. So we have a live camera image that points at the physical object and that allows to spin the table remotely. And then read the comments that are already there and add new ones. So once this comment is then submitted, it will appear on the projection. and trying to also keep a version history and archiving things. Once there is a new model placed, well, more like a revision placed, it will capture this model again and then provide a timeline of the different revisions that come with, that are available from this model, and other models will be tracked and sorted in different timelines. After some iteration, then it's possible to go through those different iterations, and when you spin the actual model, you see that the virtual model on the screen will align to that. So it's easy for comparison. So now let's have a look at the implementation. As I mentioned, we have the pedestal, which should promote the object, and on it there is the motorized turntable with a projection surface. We have a computer keeping track of the rotation and then adjusting the projection on top of it accordingly. And we have a camera that captures the object and shooting this range of images. And we have a second camera which provides the IP, which provides the web access. Any browser-equipped device can be used to access it. And moreover, there's a touchscreen in the background which accesses the archived versions. A closer look at the rotation platform, it shows that we have a wooden platform with a note pattern on it for interaction, and it's wooden because for the reason that an NFC reader, or more or less the NFC antenna, can easily detect the IDs through the wooden base plate. And we have a rotation sensoring system with a rotation sensor and a light sensor to account for very accurate measurement that is required to keep the projection aligned. And also that it's possible to spin it manually, and the step motor then can also spin it remotely. So now head over to the feedback. So this was very positive, and especially the people at LEGO saw that working with bricks, this sharing of physical artifacts provides a lot of benefit to them. However, we also collected some negative feedback, which occurs in the rare cases when things have very subtle differences. So for instance, here you can see a picture with actual 3 different chairs, and it's nearly impossible to see what's what's the difference. Actually, it's the curvature of the armrest, and without touching it, it's very hard to see any difference there. So coming back to these benefits that I was talking about at the very beginning, which benefits do we actually cover? First, we have the intuitive creation and modification. Well, we keep that for the local part, and this is nice because we don't have to actually worry so much about the 3D and the CAD modeling anymore. The same is with the haptics. Locally it's preserved, but we can't really have it with remote objects and also with archived objects. It's a little different for the geometric properties. Here we can do more. We can actually capture the model from different perspectives, and then have a look at it while spinning it, the turntable locally and also remotely. And the most thing that we can promote and help to benefit from is the communication, where we actually provide an asynchronous way to send notes and to exchange information. So concluding, we built Ketchup 360, a system to provide benefits to physical objects, and we did this with 2 features, or 2 main features. First, storing the artifacts for later comparison, and second, also providing a way to share these mockups over distance. Thanks a lot for your attention, and I'm happy to answer your questions.
Thank you. Are there questions? I have one. I thought maybe you could also invert the system and place a camera on the table. So do you have any applications in mind that would be useful for that setup? Can I get a bit closer? You know, if you place a camera on the table, you could actually capture not an object, but the environment around. So that would probably also have kind of benefit for designers.
Well, I think that there are definitely benefits to that, especially in the synchronous interaction, when you actually also want to interact with people, maybe sitting around a table and having a look at objects in a synchronous way. Our work was more focused on asynchronous interaction and storing storing information over longer periods of time. But yeah, I think there's definitely potential also for that.
I have another question. So you got feedback from people from Lego. Were these designers, like product designers, or what kind of people did you ask to kind of give you feedback on the system?
Yeah, actually, we are working with the Lego Future Lab division, who are designers on, well, not the next generation, but the generation after that on Lego, and they both, well, they consist mainly of product designers and marketing specialists, and yeah, they're working in both worlds, very much digitally, of course, but also like the way of working with physical artifacts.
Okay. Cool, thank you again for the talk.